Here we're asked to find the cube root of the complex number 4 minus I. Again, we're looking for just the principal root, and we're looking for it in rectangular form, a plus bi, where a and b are real, and rounded to the nearest hundredth, which is sort of a tedious thing, but is easy enough to do once we have it in cis form. In fact, all of this is easier to do if we're in cis form, so we're going to take our given z, and I'm going to represent it as 4 minus I, and I want to make this into r and theta. So I'm going to say, well, r is the square root of the real part, plus squared, plus the imaginary part's coefficient squared. We don't include the I here, it's just a flag telling us which is real and which is imaginary. So this becomes the square root of 16 plus 1, or the root of 17, which is not a particularly convenient number, but it's fine, it's a perfectly normal number. And then theta is the inverse tangent of the imaginary part over the real part. All right, so the inverse tangent of minus a fourth. And that isn't one that we know offhand, and that isn't a particularly special angle, so we're going to throw into the calculator pretty early. I'm going to say this is about minus 14.0 something. This tells us that we can combine these two and say that our original number can also be written as root 17 CIS of minus 14.0 degrees. And that's convenient because de Moivre's theorem tells us that the principal value of, say, the cube root is going to be r to the 1/3 cis of theta over 3. So here it's going to be root 17 to the 1/3, which is some ugly number, cis of minus 14.0 degrees over 3. This is where you probably want to grind this out in the calculator, and you end up with something like 1.60 cis of minus 4.67 degrees. And that is the principal value of the cube root of 4 minus I. For reasons beyond understanding, the textbook asks you to then turn this back into a rectangular form, and we're going to do that, but we'll do it on the next page. It isn't really part of this problem, it's just an added thing layered on top, because it says we know how to convert any cis form number into a rectangular form. Alright, so the thing we have is the principal value of the cube root of z, which we found before was 1.60 times cis of minus 4.67, and the key to all of this is going to remembering that cis ends up meaning cosine plus I sine. And then we just put in our other stuff. So it's really 1.60 times the complex number cosine of minus 4.67 degrees plus I times sine of minus 4.67 degrees, which is just a little bit of distribution, and mostly it's throwing into a calculator and figuring out what the cosine and sine of that weird angle is. And if you grind that out, you get something like 1.60, which is not surprising because we're at a small angle, plus I times minus 0.13. This would probably normally be written as 1.60 minus I times 0.13. And there we go.